Okay, so now we're going to talk about how to predict values using our line of best fit. Okay, so the example that they have been kind of utilizing was that price of square footage, and then the square footage, and then the price of the house. And so now we are looking at how to put values. So, for example, we did not have a 2,800 square foot house. So what they're doing here is they're giving us a square footage, which is an X value. And we're basically going to plug that in for X into the equation. And then we will calculate out what that looks like. Okay. Now, we're going to look at a couple different examples here. Okay. That we're processing. And so I'm going to bring this down. So let me go here. Okay, and so we're going to be looking at this one. So we've got, this is the budget in millions of dollars for selected organizations that received U.S. government funding for arts and cultures in 2006 and 2012. And so what I'm worried about here is I just want us to look at the table. And so we have the Corporation for Public Broadcasting, the Commission of Fine Arts. We have the National Gallery of Art, the Kennedy Center for Performing Arts, and the Institute Museum and Library Services. And so this is our data. Now, we're not going to be using the 2006 or the 2012 as we go to our calculator. So, but I'm going to push us in. So here's our calculator. I'm going to clear our screen. And I'm going to go to Stat and Edit. I'm going to clear my list. So again, I'm going to highlight the L1 or the L2. I'm going to press Clear and Enter. And then I'll go to the other one and I'll press Clear and Enter. And I'm going to put this data in. So we had 460 for the Corporation of Public Broadcasting. In 2006, we had 2 for the Commission of Fine Arts. We had 95 for the National Art Gallery. 95. We had 18 for the Kennedy Center, and then we had 247 for the Institute of Museum and Library Services. And then for 2012, those numbers were 444, 2, 128, 23, and 232 respectively for those. So again, I'm going to do Stat. I'm going to go over to Calc. I'm going to pick option 4 and enter enough times until I get an equation. And I'm going to write my equation up. So y hat is going to be 0.9388 x. Okay, again, following that y equals ax plus b form that they give me. And then I have plus 11.467, okay, because that's going to round a couple of times there. So that is our equation. So now I've written that down for us. Now it asks, if 2 institutions have budgets that differ by $20 million in 2006, how much would you predict their budgets to differ by in 2012? So what I'm going to do is I'm going to pick 2 numbers that are 20 apart. So I'm going to pick 0. Okay. So when I plug this in, I get 11.467. And then I'm going to plug in another number that is 20 away. So I'm going to pick 20. Now you could pick 10 and 30. You can pick any 2 numbers. Okay. And for this one, I get 30.243. Now what I'm doing here is here, the 0 and the 20 is putting them at 20 million apart in 2006. This is now giving me the projected budget of where they would be in 2012 and the projected budget for 2012. So now to figure out how far apart they are in 2012, I'm going to subtract this 30.243 and the 11.467, and I get 18.776. So I would predict that in 2012, those budgets would have been 18.776 million, because that was the units that they gave us, dollars apart. Now, the next one it said is predict for 2012 if their 2006 budget was 240. Okay, so if their 2006 budget was 240 million, they're asking us to then project up. So this is just a straight plug in. So I've got 0.9388 times 240 plus our 11.467. And when we calculate that up, we get 236.779. So we would anticipate that their budget in 2012 would have been $236.779 million. Okay. So let's take a look at another one. Okay. So this one is going to be the one that we're fixing to look at here. Is going to be one for carbon dioxide levels in non-US countries versus the US. Okay, so I'm going to zoom down here just a little bit so that you can see this a little bit better. So we're not going to worry about the year. Okay, we're just going to use the non-US and the US. Excuse me. Yes, for the non-US and the US. And so it says compute the regression predicting US. So that means US is going to be our Y values from non-US emissions. So that'll be our X values. So we're going to go put this data in on our calculator. So let me go back to our calculator. Again, I'm going to press clear so I just don't have anything on my screen. Stat and enter so that I can go put my stuff in. I'm going to clear. I'm going to press clear and enter to clear my lists. And now I'm going to go put this data in. So we had 3.6, 3.6, 3.3, 3.3, 3.4, 3.3, 3.2, and 3.3. And then over here, I've got 19.2, 19.0, 19.7, 19.5, 19.7, 19.8, 19.6, and 20. Okay, so again, I'm going to hit stat. I'm going to go over to calc. I'm going down to option number 4. I'm going to press enter enough times until I get my equation. This time we have a negative, and that's fine. We still just write it up. So I've got y hat is going to be negative 1.7258x. B is positive. Now, if B was negative, I would put subtract. Okay. I'm not going to write plus a negative. We'll just put subtract, but this is still positive. 25.3871. Okay. Okay. And so now we're going to, they ask us, okay, again, if they differ, okay, if they differ by 0.2 from one year to the next, how will these differ? So I've got y hat is going to be, and I'm going to, again, pick two numbers that are 0.2 apart. So I'm going to pick 0. And then I'm going to pick 0.2. Okay. So we're going to do okay, so we get that this is 25.0419. And then we will subtract those those two. Okay, so I'm going to have 25.0419 minus our 25.3871. And again, I'm just pulling a calculator up to calculate this really quickly. And I get that this is negative 0.3452. So what we would expect would be that if they differed by 0.2, then the US, okay, would have dropped, okay, or there would be a difference of 0.3452 for that, okay? Now, it asks, predict the emissions level if the non-US is 3.4. So this is just a straight plug-in. So we've got y hat is going to be negative 1.7258 times 3.4 plus our 25.3871. So I've got negative 1.7 times 3.4 plus 25.3. And we get 19.5194. And again, you could move that to however many decimal places that they particularly ask you to do for that. Okay. Now, one other scenario that may be presented out, okay, would be if they happen to give you the slope and the y-intercept, okay. Just they outright said it. So they said something like the intercept was 58.751. And this one they were talking about experience, which would be our slope, was 2.3738. Okay, when these were done. If we were to write an equation line, again, experience here is going to be our slope. So we've got 2.3738x plus 58.571. So if they just handed it to me, I would then create an equation. And if they wanted us to then predict they were talking about the number of years of experience is what X represents here. If they wanted us to do for 5 years of experience, then we would do 2.3738 times 5 plus 58.751. So 2.3738 times 5 plus our 58.571. We get 70.62. And so this would be the idea of kind of where their salary would be in thousands. So they would be making 70,000 and some change when that was done.